Hello, my name is Tyler Graham, and this is my MGQ 201 final project. For my hypothesis, I wanted to show the relation between Netflix, GPAs, and studying. I wanted to calculate the average amount of hours per week a typical college student would spend watching Netflix. I also wanted to see what their GPA was and how many hours a week they would study. I did this because I know I watch Netflix fairly often, and I know I have friends that watch Netflix very often, so I wanted to see if the amount of Netflix we watched a week had any impact on our GPAs or hours of studying. But I used a voluntary response sampling method, so I sent this out in a Google form to a random amount of people. I provided a Google Doc form or a Google form, and I sent it out to a random number of people. I was able to get back 36 responses. I had to not use two of those responses because, as you can see on this first question, it says, "Are you a college student or student in college?" And one of the responses was no. I also could not use one other response because they did not know their GPA. But as you can see, I got 36 responses. My first question was, how many hours a week do you spend watching Netflix? Second question was, what is your GPA? And third was, how many hours a week do you study? These are the results I was able to obtain from the survey. I got 34 results in total. For Netflix being my variable one, its max was 30 hours, minimum 0 hours, average of 5.47 hours, medium 2.75, no mode 34 in total. Standard deviation was 7.95. For the GPA, it had a max of 4.0 with a minimum of a 2.8. The average was 3.47 with a median of 3.4. For variable 3, hours of studying, the max was 56 with a minimum of 0. The average amount was 9.06 hours. Median was 5 hours, and the mode was also 5 hours. The standard deviation for that was 9.91. With that information, first off, I was able to create a frequency table with my count being 34. That put my k value at 6, and I was able to calculate estimated class width to be 5. My lower bounds were 0, 5, 10, 15, 20, 25, and those went up to 4.9, 9.9, 14.9, 19.9, 24.9, and finally 30. There were 21 students who were in the range of 0 to 4.9, 6 students from 5 to 9.9, 3 from 10 to 14.9. There's actually no students in the range of 15 to 19.9, 2 students from 20 to 24.9, and the last 2 students were from 25 to 30. From there, I was actually able to calculate the confidence interval using a confidence level of 95%. My critical value came out to be 2.0345. My margin of error was 2.7752. And then my confidence interval was from 2.9601 to 8.5105. Here's just a quick graph for the confidence interval for mu. As you can see, a majority of the students were in fact from 0 to 4.9 and 5 to 9.9. The red bars are to represent the lower and upper confidence levels. I then moved on to the hypothesis testing, where the no hypothesis was 9.8 hours. On the website, it was stated that the average per day was 1 hour and 24 minutes. I was able to calculate that out to about 9.8 hours a week. And so my alternate hypothesis was that it was not equal to 9.8 hours a week. So with X bar being 5.74 and sigma being 7.95 and a confidence interval or level of confidence of 95%, I found my test statistic being negative 2.97989 and a very small p-value of 0.002884. My two-tailed z-test for the mean had an alpha risk of 0.05 and a p-value of 0.002884. Because the p-value is less than the alpha risk, I can reject the null hypothesis and assume the average time spent watching Netflix is not equal to 9.8 hours. After I completed the hypothesis testing, I was able to move on to my first regression, where I compared GPA to hours of watching Netflix, GPA being the X value and Netflix being the Y value. For my correlation coefficient, it is at about 38% or 0.38. I have it as negative 0.038 because for the GPA under coefficients, you can see that it's a negative value. So there is actually a decline, or I'm expecting a decline in the graph. And this proves that there might not be a very strong correlation between someone's actual GPA and how many hours of Netflix they watch, but there's still some correlation. Looking at the R-squared, it's about 15%, which means that there might not be much explanation in the relation between GPA and Netflix to say that the reason that the hours of Netflix is going up or down is because of someone's GPA or vice versa. Here's just a quick look at what the graph of that first regression would look like between the GPA and hours of watching Netflix. As it predicted in the correlation coefficient being negative, there is a downward trend line. And there also seems to be a correlation between more hours of Netflix produces a lower GPA, while higher GPA results from less hours of Netflix. For the second regression, I again used Netflix as my y-axis, but this time I used hours of studying for the x-axis. And surprisingly, I saw with the correlation coefficient that it was going to result in an upward trend slightly at 0.16. R-squared is also again very low at about 2.5%, showing that there is not really any explanation for study increasing having an effect on hours of Netflix being watched. Here's that graph between hours spent studying and hours of watching Netflix. I was actually surprised to see that there was an upward trend for the more hours that you spent studying, you actually also watched more Netflix. Here are my closing thoughts on why I believe I could have made mistakes. It's hard to assess the individual intellectual ability of each of these students. So they could have high GPAs, but they also may not need many hours of studying, while others could have lower GPAs but spend many hours studying. Because of this, I was working with a smaller sample size, which makes it more difficult to calculate more accurate representation of the whole.